Hello, my name is Matthew Grushi, and welcome to the demonstration and verification video for the LA-12 battery capacity tester. The breakdown of this video is going to include a description of what a discharge test is and how it works, a quick view at the block diagram of the LA-12 battery capacity tester. Then we're going to go through and take apart the physical package and match up the parts from the block diagram to the package. Then we're going to quickly verify the specifications given for the LA-12's brochure and report. Then we will complete the video with a demonstration of a complete battery discharge test given as a time lapse for a 12-volt lead-acid battery. Okay, before going into the specifications of the LA-12, we're going to give a brief overview of how it determines the capacity of the battery. So a lead-acid battery has a common kind of method of determining its capacity called a discharge test. That's when you take a 100% or fully charged battery, then you pass it through a load and discharge it to a specified cutoff voltage. The cutoff voltage is just a safe value to discharge the battery to that will reduce any long-term damage. And the battery is discharged to this level because as a battery's capacity decreases for a lead-acid battery, its voltage also decreases. So we can go cutoff is equal to safe. And for the LA-12 discharges to a cutoff voltage of 50% capacity, which is equal to 12.06 volts. And then we can determine the capacity by using an Arduino to sample and monitor that discharge. So the battery's voltage, as we said, throughout time while it's discharging is going to decrease. Let's say that right here is our 12.06, our 50%. So we're going to reach this point and stop. We want to calculate the capacity in amp hours. That can be done by taking a samples within small increments of the discharge. For each of those has a time dt, which is the difference in time, and the current measured in amps at that time. So here is voltage, is equal to I R. For I, we can just measure as V over R, where R is the resistance of our load. Then if we get the sum of all of these small incremental capacitances, then we can get the current times time, which is equal to capacity, which is equivalent to the amp hours. And that's how the LA-12 determines the capacity of the battery. Because this is the 50% cutoff voltage here, this value would have to be multiplied by 2 to get the estimate of the total. Next, we're going to give a quick overview of the LA-12's block diagram. So the LA-12, as we just determined, needs to discharge the battery to calculate its total capacity. So the Arduino right here is controlling the discharge with a MOSFET, which is acting as a switch, to determine whether the load should be applied to the battery or not. The current will pass through the load and back in, going past the current resistor, which is feeding into the Arduino, and a voltage monitor to check the cutoff voltage of the battery. There are also buttons and a buzzer for user inputs to start and stop the test, the LCD display to output parameters, and the connection to LabVIEW to support the data logging feature of the LA-12. Finally, a power supply provides power to the Arduino, and it's a 9-volt 2-amp source. Okay, now we're going to give a quick overview of the LA-12 package. So this is the LA-12 battery capacity package. It is a nice light little Ziploc container here. Inside we have the Arduino. That it has a hat on top of it, connected with pins, and then the hat has terminal blocks soldered onto it with all the wire connections to make sure everything is good and secure. and the top just pops back on. All of the other components are on top of the LA-12 soldered to a breadboard. Here is the LCD display that outputs the test parameters, the current sensor. On top we have our battery and load connectors, which are 2 terminal blocks. And we have the switch for controlling the load, which is a MOSFET, and a LED indicator for when the load is on and off. Over here we have a voltage monitor, which is just a voltage divider to bring the battery's 12 volts down to a safe level for the Arduino. And then Schottky diodes and resistors as current and over-under voltage protection for the Arduino. Beneath the LCD screen we have the start and stop button, which will start and stop the discharge test, and then the reset button. The reset is connected directly to the Arduino's reset low pin and will reset the Arduino's programming. On the side, we have the LA-12's USB connection to connect to LabVIEW for data logging, and the power supply connection, the 9-volt 2-amp DC power supply for powering the tester. I will quickly connect the battery and load to give a quick little demonstration of the buttons. Okay, so now the power resistor and the battery are both connected to the LA-12 battery capacity tester. All the connections are made by just screwing and unscrewing the terminal blocks here. I'm just going to give a quick demo of the buttons. Well, I guess so. First, you can hit the reset, and the Arduino's programming will reset. And then the start button will turn on this switch here, and we'll see this little LED blink on, and current will start passing through the load, the power resistor from the battery, and it will start counting down the time. So let me zoom in here. There we go. So it's measuring the battery's capacity is 12.6 volts currently. It's showing the time of the kind of duration of the discharge test, the current passing through the resistor, which right now is around 1.7 amps, and then also the running total cumulative sum of the battery's capacity. So far we've dissipated 21 milliamp hours. Over to the side, we have the USB connection going into the laptop for the LabVIEW data logging application. Clicking the stop button will stop the discharge test, and we can see that the LED turned off again. If the battery reached its cutoff voltage, then the final calculated value would be displayed and the load would be turned off. Alright, so now we're going to start checking off some of the specifications of the LA-12 battery capacity tester from a brochure. So one of the things we had listed was an LCD display, which we already saw working properly, an audible buzzer, which you can hear when the button is pressed, and will also sound when the test is done. The buzzer is located just under the LCD display there. It is lightweight and mobile, which is demonstrated and is pretty observable in the small Ziploc container. Next, we will look at the data logging function supported with LabVIEW, and then finally we will check off the calculated capacity of a battery specification with a time-lapse video of a full discharge. The discharge is done as a time-lapse because it takes approximately around 45 minutes to complete. Okay, looking at the LabVIEW data logging capabilities. Here we have the LabVIEW application that comes with the LA-12 open on a laptop, and it is connected through this USB connection. So we can just choose the port that we want our application to connect to, right here, which is COM4. Then we can set in the serial settings for communication. These should all be the defaults. And same with the default termination and read character. Then we'll select that we want to read the port and we want to save it to a text file. All we have to do is click Run, and then we can choose I guess we'll choose a place to save it, so you can make a text file. So we'll save it here. And then the data is going to be read from the LA-12 and displayed in this window here, as well as saved to the text file. Now if we click the button and start a test, the most recent data will include the battery's voltage, the runtime, the cumulative sum, or that kind of final capacity, the incremental capacity that we're measuring, and also the time between samples. There's also kind of the current measured and also the input to the voltage monitor and the actual time that the Arduino has been running. If we open up the text file that we were just saving to, we can see that what was displayed in that window is also saved to the text file. If we go to the bottom, we can see right here is this time when we had the test running and the load turned on. Okay, the next specification we're going to verify is that the LA-12 can determine a battery's capacity. So we're going to do a discharge test on this battery. This battery is 7.2 amp hours, but that's at a very low discharge rate. We're going to be discharging it at 1.7 amps. And so the actual expected capacity that we're going to get based on the manufacturer's datasheet is somewhere close to around 3,000 milliamp hours. Now this is a well-used battery, so we should actually expect, instead of the nominal, something decreased because of the damage, well not damage, but the wear that's caused by cycles done on a lead-acid battery. So enjoy the time lapse of the discharge. That is the demonstration and verification video for the LA-12 battery capacity tester. We at Grushi Electronics thank you for watching the video and hope that you are happy with your product. Thank you.